In my today's lecture, I want to discuss the biomass energy. Now, in this lecture, I will discuss the introduction to biofuel and biomass, advantages and disadvantages of biofuels and biomass system and biomass sources, classification of biomass, contribution of biomass and biofuel in global energy mix, biomass and bioenergy flowchart, and the biomass production for energy farming. Biomass is the term used for all organic material originating from plants, including algae, trees and crops, and is essentially the collection and storage of the sun's energy through photosynthesis. Biomass energy or bioenergy is the conversion of biomass into useful form of energy such as heat, electricity, and liquid fuels. The biofuel is the production of the types of fuel we use in our vehicles, though normally and typically diesel, from the plants or other organic matter rather than from the fossil fuels extracted from the ground. Examples of biofuels include the methane gas, liquid ethanol, methyl esters, oils, and solid charcoal. The biofuels are produced in one of two ways. Number one is directly processing a raw plant material, such as extracting its natural oils and processing it into a type of fuel. Second is the extraction of residues or decomposing matter as a result of natural anaerobic processes, such as broken down by bacteria or algae into an alcohol substance that is called bioethanol. The biomass is different from the biofuel in that it is waste organic material such as wood and other plant matter and not a derivative byproduct that results from processing. Biomass is chopped wood, logs and kindling, grasses, leaves, brush and scrub, and the other raw organic material that may burn and produce energy, including manure and animal dung. It is organic, carbon-based material that reacts with oxygen in natural metabolic processes and in combustion to release heat that, especially if at the temperature is greater than 400 degrees centigrade, may be used to generate the work and electricity. In the past, and indeed in areas where there are few trees to burn as fuel, that is Arctic cycle, people may burn bone or as a source of fuel. Biomass energy or the bioenergy is the conversion of biomass into the useful forms of energy such as heat, electricity, and the liquid fuels. The term bioenergy is used to describe both the biomass and biofuels. The bioenergy is by far the most used renewable energy resource by the energy value, being about 10% of global total primary energy supply if non-commercial firewood for cooking and the commercial use of the waste are included. Despite the historic use of biofuels, there is great potential for the more energy efficient and sustainable use in both the developing and the developed countries. The advantages of biofuel and biomass. Number 1. Whether the burning the organic material itself or resulting substances that are processed from the breakdown of the raw organic material, as it is organic, it is renewable. There are not a finite resource so long as we continue to plant the vegetation to replace that which we harvest. Flexibility of source is a considerable advantage for the biofuels and the biomass, especially when the producing liquid fuels such as ethanol. Different topographies are suitable for the different types of crop, which means that most countries should be able to produce the biofuels. It is not limited to one crop type. The other obvious advantage on a slightly related note is localizing supply and not being dependent on international trade for fuel, just like petrol or diesel. Biofuel or biomass that is produced in a shorter radius will have a much lower carbon footprint for having eliminated the transportation process of getting the fuel from source to the consumer, and of course increases energy security. Too many biofuels are a stopgap at the best until we can find something cleaner and greener than ethanol. The energy output of the biofuels and the biomass is much lower than the conventional fossil fuels, and much greater quantity is needed to produce the same energy output. This is counterproductive to the lower carbon emissions of the fuel type. Now the disadvantages of this type of biofuel and biomass. As a knock-on effect, more areas of the land will be required to produce the biofuels and the biomass, meaning that we will need more land as a planet that is a finite size. On a related note, and one of the major contentions of the use of biofuel and biomass is how we can justify turning over virgin land to the agriculture to supply the world with the fuel and the energy, while half the world's population still starves. Aside from the ethics, more pressure on the land will mean less space to produce food and higher food prices and more water use turned over to keep our energy needs supplied. By volume of land, the biofuels and the biomass production for the purpose of energy is simply not that efficient. The success of biomass system is regulated by principles that are often not appreciated. Every biomass activity produces a wide range of products and services. For instance, where the sugar is made from cane, many commercial products may be obtained from the otherwise waste, molasses and fiber. If the fiber is burnt, then any excess process heat may be used to generate the electricity. Washings and ash can be returned to the soil as the fertilizer. Some high-value energy supplies require a greater amount of low-value energy for their production, such as the electricity from the biomass thermal power, ethanol from the starch crops, methane from the animal slurry, etc. Such apparent efficiency is justifiable, especially if the process energy is from otherwise waste material, just like straw, crop fiber, forest trimming, and the animal slurry. The Fuel economic benefit of the agro industries is likely to be widespread and yet difficult to assess. One of many possible benefits is an increase in local cash flow by trade and employment. Biofuel production is likely to be most economic if the production process utilizes the materials already concentrated, probably as a byproduct, and so available at low cost or as extra income for the treatment and removal of waste. Thus, there is to be a supply of biomass already passing near the proposed place of production, just as hydropower depends on a natural flow of water already concentrated by a catchment. Examples are the wastes from animal enclosures of carts and trimmings from the sawmills, municipal sewage, husks and shells from the coconuts, and the straw from the cereal grains. It is extremely important to identify and quantify this flow of biomass in a national or local economy before specifying likely biomass developments. Unless concentrated biomass already exists from the previously established systems, then the cost of biomass growth and or collection is often too great and too complex for the economic benefit. Short rotation crops may be grown primarily for energy production as the part of intensive agriculture. However, within the widespread practice of agricultural subsidies, it is difficult to evaluate the fundamental cost of effectiveness. Negative and unjustifiable impacts of extensive biomass fuel production on a large scale include the deforestation, soil erosion, and the displacement of the vital food crops by the fuel crops. The biofuels are the organic materials, so there is always the alternative of using these materials as chemical feedstock or the structural materials. For instance, the palm oil is an important component of soaps. Many plastic and pharmaceutical goods are made from the natural products, and much building board is made from the plant's fiber constructed as composite materials. Poorly controlled biomass processing or combustion can certainly produce unwanted pollution, especially from the relatively low temperature combustion, the wet fuels, and the lack of oxygen supply to the combustion regions. Modern biomass processes require the considerable care and the expertise. Using the sustainable bioenergy and the other renewables in place of fossil fuels abates the emission of fossil carbon dioxide and so reduces the forcing of climate change. Recognizing this is a key aspect of climate change policies. Now come to the natural and managed biomass system. The initial energy of the biomass oxygen system is captured from the solar radiation in the photosynthesis as shown in the figure. This is the biomass absorbs carbon dioxide through the process of photosynthesis by the plant, and after when released in combustion, the biofuel energy is dissipated, but the elements of the material should be available for recycling in natural, ecological, or agricultural processes. Thus, the use of industrial biofuels, when linked carefully to the natural ecological cycles, may be non-polluting and sustainable. Such systems are called the agro-industries, of which the most established are the sugarcane and the forest products industries, However, there are increasing examples of commercial product for energy and materials made from the crops as a means of both the diversifying and the integrating agriculture. The associated energy captured in the photosynthesis is 2 into 10 to the power 21 joule per year, that is 0.7 into 10 to the power 14 watt. Of this, about 0.5% by the weight is biomass as crops for the human food. Biomass production varies with local conditions and is about twice as great per unit surface area on land than at sea. Biomass is the primary source for about 10% of the mankind's energy use, which is similar to the global use of the fossil gas. Uses in approximate proportions include the 70% as mostly uncommercial traditional fuel wood for domestic cooking and heating, predominantly in developing countries, but also including the significant amounts in the rural areas of the mature economies. 10% as the fuel for electricity generation, including combined heat and power, that is called CHP, and the 10% for the non-domestic processes, heat, and the 10% for the biofuel component of the vehicle fuel, which is rapidly increasing in both absolute and the percentage terms. Some countries are notable for their use of bioenergy, including Brazil, that is 31%, and Sweden is 23%, and Australia is 18% of their total energy usage. The carbon in the biomass is obtained via the photosynthesis from carbon dioxide in the atmosphere. When the biomass is burnt or digested or decays naturally, the emitted carbon dioxide from the biomass itself is recycled into this atmosphere. So first the biomass is absorbed carbon dioxide through the process of photosynthesis, then the biomass is sustainably grown, managed and harvested. Then the biomass is burned to generate heat and the power and generate the carbon dioxide, and then the carbon dioxide is once again stored in the biomass is returned to the atmosphere. This is the biological biomass cycle. So the energy storage of the solar energy as biomass and biofuels is of the fundamental importance. In the stable ecosystems, the biomass grows at the rate at which it decomposes. Consequently, energy obtained from biomass itself is carbon neutral. However, the fuels used today in agricultural and the forestry machinery and in the production of fertilizers are predominantly the fossil fuels, which are not themselves carbon neutral. Therefore, the bioenergy, if obtained with no or the insignificant amounts of the fossil fuel, contrast with the energy from the fossil fuels, from which the extra carbon dioxide is added to the Earth's atmosphere. Thus, using the renewable bioenergy in place of fossil fuels is an important component of the medium to long-term policies for the reducing greenhouse gas emissions. Now this is the biomass sources. So from the biomass, the wood and the non-wood like from the bamboo and the rattan, residues, the sawdust, wood chips, construction and the demolition of the paper and logging residues, the wood, that is hardwood as the oak, maple and the poplar and teak type of woods, softwoods just like rubber wood, fir and the redwood or pine are used, and the plant fiber, the residues are the whale palm frond, palm trunk and the baggage, straw. The cultivated for this plant fiber, that is kenaf, jute and hemp and flax and coir. From the animal, the wool, silk and hair are the residues. From the aquatic plant, the algae and the hyacinth. The animal residues, the municipal solid waste residues, the industrial residues, the sewage. These are the other renewable sources for the biomass and biofiber. So from this figure we will see that this is the forest residues, this is the agricultural crops. After burning we will get the biogas, the aquatic biomass, the agricultural residues, the root crops, the silage from the municipal solid waste. Then it will go to the biorefineries making some energy through, and it will at last store in the power plant and the grid, and the energy will be supplied to the modern cities. So this is the actual biomass cycle or the biomass sources. Then we will go to the biomass by energy crops, that will be annual grassy crop, perennial grassy crop, whale crops like the whale seed crops or the whale tree crops, and the lignocellulosic crops. The biomass by the residues and waste, example is biogenic waste from the urban and the industrial sector, residues and waste from the agricultural sector, residues and waste from the forest sector. So now the elaborate discussion of the biomass sources or the classification of biomass, that is biomass by the energy crops, that is annual grassy crops. The grassy monocotyledon plants form the bulk of the modern broad-scale agriculture. Annual grassy crops include the cereal as grains, barley, oats, rye and other minor cereals, sugar beet, sugarcane, forage crops as clover grass species. Seeds from these cereal crops, tuber and the stem of the other plants tend to be good sources of the starch, which can be used by technological processes for biofuels or bioenergy production. Selective breeding, particularly for no-food crops, has been used to alter the seed or the plant biomass ratio in many species, which with large increases in seed yields. Biomass by the energy crops, the second type of crops is the perennial grassy crops. This type of biomass can be used as the bioenergy feedstock when the economics are viable. Fast growing nits and canes, that is Arundinodonax, elephant grasses, are the examples of the grassy crops that can make good use of the nutrient availability to increases the biomass productivity. But at the same time, some other agronomic characteristics represent yet the weak points, such as the floral sterility, prohibitive cost for the crop establishment, low relative harvest mechanization, high moisture during the harvestable product and the high ash content. Karun and the mischance are the other energy crops with the Mediterranean characteristics of the growing with low water. For this reason, they are obtaining high interest and research activities in agronomic and genetic fields with the programs of improvement. Biomass by the energy crops, that's like whale crops. Whale crops include the annual whale seed crops or the perennial whale tree crops. Whale seed crops means from an agronomic point of view, the whale seed crops have an evolutionary history different from the cereal crops, and therefore can have an additional benefit as a brick crop in reducing plant soil pathogens. The most representative whale crops in the world are rapeseed and sunflower. Vegetable oil is usually extracted through the mechanical pressing and or solvent and is used for the food preparation, soaps and the cosmetic preparations also. The lignocellulose part of the whale crops, which is traditionally used as mulch or fodder, can also be combusted for the heat and power, while vegetable oils can be used for higher value bioenergy applications, especially as a diesel replacement. Vegetable oils deriving from these crops and the modified in methylene esters are commonly called the biodiesel and prominent candidates to become the alternative diesel fuels. The whale tree crops, actually a number of tree crops produce oil, just like a palm, coconut, macadamia. The palm oil is particularly used in the developed countries to produce both the edible oil than the primary products for the biodiesel. The production of the biodiesel from the different non-edible oil seed crops has been extensively investigated over the last few years. Oil tree crops with their lower food values can be resource for bioenergy, and as the perennial crops provide water and carbon sink benefits. Non-food crops will also not display spikes in value associated with the food supply and demand issues. Many food oil producing species such as Jatropha can be useful for the bioenergy and are often promoted as not competing with the food crops. However, these species can display many properties associated with the weeds and can become subject to bans in order to limit the infestation risk. The lignocellulose crops, corn and the soybeans are the annuals. Differently forms of lignocellulose bioenergy crops are typically perennials. Lignocellulosic crops include the perennial grassy crops and other tree crops. Herbaceous species include the crops as the switchgrass, the Panicum virgatum, the Phalaris aurantiacea, and the Miscanthus, that is Miscanthus supplements. Hardwood species include the woody species such as willows, salix sap, poplars supplements, and the eucalyptus and others. Among them, the poplar and the miscanthus and the switchgrass have received particular attention for the high biomass yield, efficient nutrient utilization, low erosion soil potential, carbon sequestration capability, and the reduced fossil fuel input requirements in comparison with the annual crops. Several research activities have been carried out on poplar, which is considered one of the most important plants for its short rotation. This has permitted to develop the important genetic programs with an increase of varieties and clones exportable around the world. Other woody crops as the eucalyptus let produce biomass at the warmer conditions as Mediterranean climate. Biomass by the energy crops, the primary requirements that a biomass crop must satisfy to be considered a viable source of green energy. No conflict with the food crop accrues or the food supply chain, scalability to meet demand for large amounts of electrical energy, biofuels, biogas and other green energy products, continuity of supply with consistent quality, low and predictable cost for the 20+ year life of a biomass power plant or the biofuel refinery. Today, the biomass electricity is generated using the agricultural and forestry waste such as wood pellets from the sawdust and the wood bark, sugarcane bagasse, which is the left over after the juice is squeezed out, corn stover, wheat straw, and the rice husk. Future liquid biofuels and the biochemicals are also targeting agricultural waste as a feedstock. The biogenic waste from the urban and the industrial sectors. The waste from the industrial and the municipal sources is an attractive biomass source, especially if the organic fraction called the biogenic fraction is considered. On the basis of the waste hierarchy concept, to reuse part of the biogenic fraction of the municipality and the industrial waste could be an interesting biomass for energy recovery by anaerobic digestion process, which I will discuss in the next lecture. A particular consideration has to be done on the use of waste cooking well for biofuel production. The production of biodiesel from waste cooking well to partially substitute petroleum diesel is one of the measures for solving the twin problems of environment pollution and the energy storage. The biomass and residues and waste, that is residues and waste from the agricultural sector. Major agricultural residues include the crop residues, straws and husks, olive pits and the nut shells. More in particular, the residue can be divided into two general categories. One is the field residues, that calls the material left in the field or the orchards after harvesting as stalks, stems, leaves and the seed pods. Second is the process residues, that means the materials left after the processing of the crop into a usable resources, husk, seeds, bagasse and the roots. Some agricultural residues are used as animal fodder for soil management and in manufacturing. The residues and waste from the forestal sector. Still now, most of the wood derived from the forestal sector is a predominant source in non-OPEC and developing countries, and it's also used as the principal fuel for small-scale energy production in rural areas where the gas fuel is not common. It well competes with the fossil fuel and it is used both in the houses for cooking and the water heating and in commercial and industrial processes for the water heating and the process heat. Alternative use of the wastes from the forestry of industrial activities connected as sawmill represents an attractive sources of biomass and a successful example for energy production by residue. Normally the forest use residues are considered better fuels than the agricultural residues, but their density value and the harvest system keep high their transport cost, and the net carbon dioxide emission produced for every unit energy delivered by the forest logging residues is lower than that of the produced by other agricultural residues due to fertilizers and pesticides utilized. The energy content of different plant materials determines their calorific value, that is called heat content. The CV depends on the percentage of the carbon and hydrogen, which are the main contributors to the heat energy value of the biomass. Generally, one of the most important characteristics of the fuel woods is represented by the wood density, ranged between 400 to 900 kilogram per meter cube, and the energy content generally expressed as the low heating value, that is LHV, that is kilocalorie per kg, ranged between 4200 to 5400. To get the maximum energy, the plant material should be air dried because the amount of energy content in the plant varies with the amount of moisture content. In the firewoods indicates the calorific value decreases linearly with increasing moisture content. The agricultural and the forestry wastes have the several problems, like the wood waste has other competing high value uses including construction material and the furniture made from the pressed wood products. Forestry waste also depends on the business cycle. The amount of sawdust and the wood scraps available is greater during the time of the robust home building and decline significantly, bring economic turndowns. Agricultural waste is seasonal and is not available until the food crop or the cotton crop is harvested. At harvest, there is an abundance of waste, but this must be gathered, dried and stored until the next crop is. In different seasons, waste from different crops become available and there is no consistency of the fuel or the feedstock. Reliability of the supply is uncertain. A farmer may decide from year to year what to grow, and the waste from the new crop may not be suitable for the biomass application. Agricultural waste is now expensive, although the waste originally had little value to the farmer and was often burned or plowed under. Prices have risen dramatically once the demand has. The agricultural waste market is largely a spot market with short-term pricing, and very few long-term contracts have ever been signed. It is difficult to get the biomass project financing without an assured source of fuel or feedstock at a known price. Agricultural waste must be collected over a substantial radius, say 50 km, and this presents the logistic problems, and fossil fuels are expended during the collection. Because of these issues, many biomass power plants in India, for example, are running at partial capacity because the biomass is not available, or closed down because of the fuel is too expensive to operate profitably. This is the global mix, energy mix. In 2011, the biomass and biofuel are the 10% of the total energy utilized in the world. But in 2020, this is the same as that in 2011. So there is no growth. In 2020, where the biomass and the biofuel is 10%, then it is expected in 2035 the biomass and the biocarbonates will be increased to the 11%, marginally increased. So this should be under observations or should provide some emphasis on it. The future role of the biomass in 2050 time frame, 2050 to 2100, the total projected global energy demand is 560 to 710 exajoules per year. Contribution of biomass to the energy demand is 32% to 46% from the IPCC source. From the shale, it is 15% to 22%. So role of biomass in future global energy use according to the 5 different studies. Studied by IPCC, studied by shale, studied by WEC, studied by Greenpeace, and studied by Johansson. So these are the future role of biomass. The picture shows that in 2100, the biomass energy in the world should be from 200 to maximum 500 exajoules per year. So now the biomass and the bioenergy flowchart. The biomass for bioenergy comes either directly from the land as dedicated energy crops. This is the dedicated energy crops, or from the residues generated in the processing of the crops for food or other products such as pulps and paper from the wood industry. Process residues like stalks and straw, harvest residues, forest slash, baggage, dung, etc. Another important contribution is from the post-consumer residue streams such as construction and demolition of woods, pellets used in transportation, and the clean fraction of the municipal solid waste. That is municipal solid waste. That means MSW, yard, trimmings, construction, and demolition of the woods by the consumers. The biomass to bioenergy system can be considered as the management of flow of solar generated materials, food, fiber in our society. These interrelationships are shown in the figure. Figure represents the various resources types of applications, showing the flow of their harvest and residues to bioenergy applications. Not all biomass is directly used to produce the energy, but rather it can be converted into the intermediate energy carriers called the biofuels, charcoal and ethanol. This includes the charcoal, the higher energy density solid fuel, and the ethanol, this is the liquid fuel, or the producer gas from the gasification of the biomass. So now the last part, that is biomass production for the energy farming. We use this term in the very broadest sense to mean the production of the fuel or energy as a main or subsidiary product of the agriculture, silviculture, aquaculture, and also of the industrial or social activities that produce the organic waste residues such as the food processing or the urban refuse. The main purpose of the activity may be to produce the energy, but more commonly it is found best to integrate the energy and the biofuel production with the crop or the other biomass material products. Here in this table we shows the biomass source of the fuel, biomass produced, conversion technology, approximate conversion efficiency, and the energy required in conversion, necessary or optional, approximate range of the energy from the biofuel as a gist. This conversion technology I will discuss in the next lecture. Now an outstanding and established example of the energy farming is the sugarcane industry shown in the figure. The process depends upon the conversion of the crushed cane residue, that is called baggage, for powering the mill and the factory operations. With the efficient machinery, there should be excess energy for the production and sale of the byproducts. Just example of the molasses, chemicals, animal feed, ethanol, fiberboard, and the electricity. Commonly, the ethanol becomes a component of the transport fuel, and the excess electricity is sold to the local grid. In the picture A, describes the sugarcane agro industry process flow diagram. Baggage is the plant fiber residue, molasses is the sugar rich residue. B is the a 30 megawatt hour cogeneration plant in the Queensland, Australia, fueled by the baggage and the wood waste from the nearby industry. The sugarcane is growing in the foreground. Wood waste and baggage are stockpiled in the open. This is the advantage and disadvantage of the energy farming. The large potential supply, variety of crops, variety of uses including transport fuel and the electricity generation, efficient use of the byproducts, residues and waste, link with established agriculture and forestry, encourages integrated farming practice, establishes the agro industry that may include the full range of technical process with the need for skilled and trained personnel, environmental improvement by utilizing the wastes, fully integrated and efficient system need have little water and air pollution, encourages rural development, diversifies the economy with respect to the product, location and employee skill. Greatest potential is in tropical countries, frequently for developing countries. The disadvantage or the dangers and difficulties of the energy farming, that is, may lead to soil fertility and erosion, may compete with the food production, bulky biomass material handicaps transport to the processing factory, may encourage the genetic engineering of the uncontrollable organism, pollutant emissions from the poorly controlled processes, poorly designed and incompletely integrated systems may pollute the water and air, large-scale agro-industry may be socially disruptive, foreign capital may not be in sympathy with the local or the national benefit. These are the references from where I make my lecture. You should go through these references for the details. Thank you.